Question 2. This one is not the most straightforward. It's quite wordy and we've got to figure out what's going on. Okay, we've got a fungus occurring in a population of trees in two mutually exclusive types. 4% of trees have got type X. There's an unknown proportion P of trees that have type Y. Okay, so we've got then a test to see what type of fungus it's got, okay, or if it's got or hasn't got fungus, you know, is it going to come back positive or negative test result? And then we've got these 2 bullet points at the bottom which tell us 2 pieces of information: the probability of the tree testing positive for the fungus, the probability of the tree not having the fungus given it's testing positive. Okay, so let's start by drawing and labelling a tree diagram as best we can. So we're going to say, first of all, that our tree either has type X or type Y, or it has nothing. Okay, so we've got 4% of trees with type X. P, which we don't know the probability there, and therefore we don't know this branch either, this lower branch, but we do know that these branches add up to 1. So if that's 0.04, then these two must add up to 0.96. So I can label that as 0.96 minus P. So that's the first awkward bit. Then we do the test on the tree and see whether you get a positive or a negative result. Okay, and then we'll label up the second lot of branches. So if we're an X fungus, the chance of it showing up on the test is 0.95 and the chance of it missing that is 0.05. If we're a Y fungus, the chance of it showing up is a D and the 1 minus D for it not being visible on the test. And if we don't have any fungus, the chance of it showing we did, or the tree did, is 0.02 and the chance of it saying we don't is 0.98. So there's our tree diagram. So we are told, first bullet point, the probability of the tree testing positive is 0.12. Okay, so this is not dissimilar to what we normally do. Okay, there's 3 ways we can test positive. Okay, so we need to say that each of those 3 branches times and added together is going to equal 0.122. So that will look like this: 0.04 times 0.95 plus P times D plus, in a bracket, 0.96 minus P times 0.02, and that will equal 0.122. Okay, so that's not particularly helpful at the moment because we've got a P and a D that we don't know. All right, so I'm going to leave that equation for a minute and see if the other bullet point is more useful. So this one says the probability of the tree not having the fungus given it tests positive. So the probability that it's a no given that we tested positive is 87 out of 610. Okay, so if the question was to find the probability that you didn't have the fungus given that you tested positive, what you would do is you would work out this branch out of the sum of the 3 branches. Okay, and we remember we know the sum of the 3 branches is 0.122. Okay, so we can say this is the probability of not having it and testing positive divided by the probability of testing positive, if you want to use the formula. So that would be, following the branch that I've put the star, 0.96 minus P times 0.02, out of the probability it was a positive result, which was 0.122. Now that's better because we've only got P in that equation, and we're told that equals 87 out of 610. So we can solve this equation and then we can find the P. Well, we know what it should be because it says show the value of P is 0.09. So we're going to solve this, hopefully get 0.09, and then we can take that value and go back and work the D out from the first equation. So we're not doing simultaneous, we just needed the second fact first, really. So let's times up by the 0.122. And actually, let's divide down by the 0.02. And that just leaves 0.96 minus p on that side. Okay, so 87 over 610 multiplied by 0.122 over 0.02. And that gives me 87 over 100, or 0.87. So if I rearrange that, that's going to give me 0.09, which is what we wanted. But we've got enough working there for the examiner to be convinced that we knew what we were doing there. Okay, then we need to take the value of p of 0.09 and use it in this equation. Now, you could, to collect the half of the marks probably, is to just take that value of 0.09 and use that in your probability tree. Okay, but obviously to get all the marks you've got to show the 0.09. Okay, so I'm just going to work out this term, 0.04 times 0.95. So that's 0.038 plus p times d, so that's 0.09 times d, plus, then we want 0.96p, sorry, 0.96 minus p, which is 0.87 times 0.02, which is 0.0174, and we know that equals 0.122. So hop over our two decimals. That gives us 0.09d is 0.0666, and hopefully when we divide by 0.09 we'll get a decent answer for D. 0.74 sounds fine. Okay, and there we are. Not an easy question, but it was very off-putting until you started to draw the tree diagram, and if you then got going on it and gave the question a go, you might have then figured out what was going on. Okay, so you've got to be brave and try the questions even if you think they're quite off-putting looking.